Hello and welcome back to the development of the Feersum scheme compiler. So in today's episode, we're going to take a break from the SDK stuff. Well, I say take a break, it should all be done now. So we're on to something new. The plan for today is that we'll have a little bit more of a relaxing stream and go back and try and fix one of the bugs that we have in the compiler. Something hopefully fairly simple to tackle. Let's start though by going over what went on in the last stream. So in the last stream, we were working on converting our hacky MS build file for compiling using our compiler into using the .NET SDK into a proper .NET SDK. So the idea behind that is it allows us to let's see if I can get an example up. Bear with. Something like this. It allows us to define an MS build file where we say SDK equals Feersum, and then the rest of it looks just like a normal C# or F# project file, but instead of it compiling using their compilers, it uses our compiler. So the way that we've implemented it is we have this new Feersum.sdk project, which is actually a no targets file. So we don't actually do any compilation here. It just copies some files into a NuGet package. So our NuGet package has two folders in it, SDK and targets. In the SDK, we just import the Microsoft SDK properties file. In the targets, we include the Feersum SDK targets file if you are in a scheme project. And then all of the code for calling out to our compiler is now in here. So we've got a few different property groups which define all of the inputs that we require for our compiler. We've got a pair of targets, the stub target for create manifest resource names, and then the important core compile. Since the end of the stream, I've done a little bit of extra work. So now we detect the host, which is what like the .NET command line executable is called. And yeah, I've added support for compiling with older versions of .NET Core too. So we emit code when it's in debug mode that uses the debuggable attribute, and that wasn't always in corelib on ASP.NET. .NET Core. So had to include that system diagnostics debug library as well. But generally, this all works, which we can show by going and cloning that gist that I just showed. So if I get the clone URL, we can git clone that thing. Nope, I've not copied properly there. Oh dear. We're not in a situation where copying and pasting isn't working again, are we? We are in a situation where copy and pasting isn't working. Let's see if I create a new terminal. No. Let's just download the zip file directly then. Feersum example. So, no. We've got this. This is the project that I just showed you on the gist. And basically, if I show you the two files, we just have the Feersum SDK, which is going to include the hello file, and then we have the scheme project. So if I do .NET build, this should work out that it needs to download that SDK, downloads the NuGet package. The NuGet package tells it to download the compiler, and then it runs the compiler. And you see, just as if you were compiling any other .NET thing, it says greetings, which is the name of our project. It's compiled to greetings.dll. So we can also do more stuff. So we could do .NET at run, because that basically just does exactly what we've just done before, builds it and then runs the resulting executable. We can do .NET pack, so we can actually produce a NuGet package if we want. And if we look in the bin folder, was it object? No, it's bin. We end up with greetings NuGet package, and that's it. We could like debug that and all the rest of the stuff if we wanted to. But on to the plan for today. So at the moment, we have 4 main phases in our compiler. The compiler starts out by parsing, which is done in the syntax, where we basically have a bunch of different functions, each of which, so this is called parser combinators. We have a bunch of different functions, each of which represents a way of parsing a specific part of our language, like in this case comments or spaces. And as the file goes on, the things that we're parsing get more and more complex because we're combining smaller parsers. So in this case, parsing a character, it uses a parser where we could choose between specific named things or blah blah blah, and then we end up right at the root where we have parse atom, which is parsing each specific element in our source file, which is either like a string, literal, vector, blah blah blah, and then parse application, which is the bracketed list of things. Then once we've parsed code, it goes through the binder, where we have a binder context which holds our state, and we have a big match expression where we're looking at each different kind of node in our tree. So if we have like a letrec declaration, we do this stuff. If we have an if, for example, we look at whether or not it's a 2 or 3 branched, like is it an if something or is it an if something else, and that kind of thing. So at the end of this, we end up with a bound tree. And part of what happens in the binder is that we identify if you have captured a value. And so the example program that we're going to talk about is this one here. So let's start by, can I copy this? Or do I need to type it out? Let's go add it as a spec. Okay, I can paste from there, so maybe it's just Firefox that's being unhappy today. I don't understand why copy and paste has become so difficult recently. So, in this example piece of code, we define a function called foo. Inside foo, we define another function called bar. Bar does a check to see if its argument is, if 10 is less than its argument. If it is, it returns the argument. Otherwise, it recurses, but making the argument for. Basically, it's going to count down until it gets to 10. We can do display foo. Hopefully this should help. And let's get a console up. And now I can use run spec self capture. What? Base name. Just misspell the file name. Probably. So this is going to compile a compiler and then run it so that we end up running the spec. And hopefully we'll see what it outputs. Reference to undefined symbol. What? Ah, yes. So we don't actually import anything. And scheme right as well. I think I raised this bug before we properly supported libraries, so the code didn't have any imports or anything. What is going on? Seems to be taking a bit longer than I would expect. Is this infinitely recursive? No, dash small a. Yeah, no, looks like it's infinitely recursive. Bar 10 if less than 10x, then x. Otherwise bar r minus x1. It's still not working, is it? Let's debug it. I can't work out what I've done wrong here. This is a great start. Test example, I think is what I want. And then this is going to prompt for the debug, which is going to be spec bin self capture.exe. Ah, yes. So .NET run. The problem here is that we've generated we can only debug it if it is ends in DLL for some reason. So project source fearsome spec bin self DLL spec self capture lib but type right now I should be able to use spec bin self capture.dll. And module was loaded without symbols because I did not compile it in debug mode. I compiled it in release mode. Spec bin self capture.dll. Symbols loaded. So if the symbols are loaded, where are we? It says paused on exception. Entry point not found. Fair enough. Okay, so we want the output type to be exe. Come on, surely. It must start working sometime soon. Spec bin self capture.dll. It's looking more positive. I think it's paused on entry, so here we are. We define something, we step into it. And then if I pause, what's happening? So we are if I think this might just be the wrong way around. If x is less than 10, yeah. Let's just try doing that run spec again. There we go, 9. Right. So with that sidetrack out of the way, the problem we have is with the generated output here. So spec bin, let's just clear that folder out, rerun the spec so that we know that what we see the IL for is what was just compiled. Oh, it should really matter because we've not changed anything yet. But in spec, let's do IL spy spec bin self DLL. Oh, exe. So IL spy dash IL. It's going to show us what we've actually ended up emitting. So we have at the top, we have lambda 0, which is the body of the script. And what this does is makes an environment, and then it puts some things into the environment by the looks of things. So, oh yeah, it'll this bit here, store element, ref, and all the rest of that stuff. It's creating, it's loading the lambda 0, which is a function declaration. It's putting it in it's wrapping it in a delegate and storing it in a slot in the environment. And then you see the store element ref there, which means put the element into the array reference type. Then it's loading the same thing out of the environment, because that's the next statement in the program. So the first, let's have a look. The first thing we do in self-capture is define foo, which is this bit. So that means wrapping we've emitted the code for the body of foo. When we're evaluating the body of the whole program, put foo into the environment, and then was it foo here? No, because this is that's not gonna be foo. That's gonna be the body of this method. It's gonna put bar into the environment. Then it's gonna load bar and call it with 10. Yeah, so it gets. Which I think means that. So script body is the overall body, which is putting lambda 0, which is foo, and then calling it. So first it stores it as a field on the program because it's a global value. So it lives on a field, not in the environment. Then it's calling it. So that means that lambda 0 is the body of foo, and lambda 0 is defined here because it doesn't capture anything, but lambda, the bar is lambda 0, which is here, but this is defined on the environment because it does capture things. The problem is in the IL that we've emitted for foo, which is this here. So I'll make it bigger again. So foo, well, that's the first problem, is the fact all these names are an absolute mess. So it'd be nice if we could rewrite them so that it was called foo and bar and stuff. But like technically, you could reassign those values, which is the reason why there's no actual name assigned to the lambda. But we could probably come up with a good starting name for it, couldn't we? And then just make sure that it never clashes. So the moment we're using lambda, and then like the next lambda would be lambda 1, and we could just like have it called foo 0 and then bar 1, and then you can still work out which one is which. So we see the local count here. We have object, an environment, and object. So if we have a look, we have store lock and load lock. So that's local 1. So we're using the environment. We have store lock 2. We have, which is, I think, what are we using local 2 for? It might just be a spill of some kind. Yeah, so it's loading bar, making a function, storing it in local 2, so it must just be using it as a temp. Then it's loading local 1, which is the environment. It needs to spill it because it needs to load the environment to be able to then push. Because then it just load lock 2 store element ref. So, because like the way it's doing this is it's making a func out of this, out of bar, and then it needs to. Right, it's actually really this bit. It's making a func out of bar, and then spilling it to load the environment, and then loading it again to store it back in. It's inefficient, but I guess it works. And yeah, we got load lock 1 again for the environment, load element ref to load bar out of it, and then we've got a call sequence, and then what's this bit down here? Load constants I4. Oh, it's making a 1 element object array. This will be the arguments. So it's saying if it is callable, then it builds up the argument array and calls call vet. Yeah. So the key thing here is that none of this part of the code references local 0. Local 0 here was the local that we added because bar is defined inside foo, and so it can't be a global, has to be a local. But bar ends up being captured. Bar gets captured here by itself. It doesn't really matter. The key point is that bar gets captured. So when we bind it, we'll initially go, we get to here, we go, oh, you want an identifier bar. Cool. I'll make a local for you. And that's local 0. And then later on, we'll go, oh, you want to look up bar, but you're in a different scope because bar's defined in foo's scope and you're in bar's scope. So in that case, we'll need to capture it. So bar, instead of being local 0, ends up being captured environment 0. So it gets moved from the locals into the environment. But what we never do is clear up that local slot. So I'm going to try and demonstrate this a little bit better with the REPL. Let's debug the REPL and copy and paste this bit in there. What's gone wrong there? Is this because it's all on one line? It needs to be all on one line. Let's just paste it all onto one line. Our REPL doesn't support multi-line mode yet. There's so many things that are nice to haves in the REPL. I think it might be an area we have to come back to quite a lot recently, soon in the future. So we have breakpoints. Let's just clear all of the breakpoints. So we are in the REPL, which is defined in the program. So read expression. REPL evaluator. What is evaluator? Go to find all references, please. Eval. This is what we want. So this is where we are given a piece of syntax and we have to go and debug it. Compile it. So the first thing we're doing is creating a memory stream, creating some compilation options, and we're calling compile, which is what we really want to have a look at. So we're resolving a target framework from our current environment because we're going to compile it to an in-memory assembly. We're getting all of the reference types, initializing the scope because we're in a script type. And then we're going to bind it. And this is the key. So I'm going to get this in the debug console. Bound. So we can see it a little bit better. So this is the bound tree for that. So it's a sequence point where we store foo, and then foo is this lambda. And then it takes no arguments, and it has a body, which is this sequence. First, we store into local 0 this lambda. And then the key here is that captures for the lambda is local 0. So then the next thing we do is something that in this compiler we call lowering. So let's go to that and find out what happens. So it's just F5. Step in. So the first thing we basically get given this root, which we then rewrite. So the root here is the whole program. We step in, we see that it creates like some kind of context and then calls rewrite environment, which is to do with like it's gone and scanned all of it. This mappings for expression has gone and produced this mapping dictionary, which is empty here because at the roots nothing is captured. And then we rewrite the environment so that there's enough space to store all of the values that we know have been captured. What we then do is recurse into rewrite expression, which yeah, I think I've just ended up stepping over the important part there. But basically it will call back into rewrite root because eventually we'll end up down at one of the lambdas and the root of the lambda ends up being rewritten as well. So let's see. If I paste the same thing back into the console again, we should end up in the same place. So yeah, lower calls rewrite root on the root. So we have no parent and the root is the global program. But then we have a parent, which is the global program, but our root is, and then I think this should be foo. So this is the, yeah, this is the body of foo. So we're storing something into local 0. So let's see what happens here. I'm just going to remove that breakpoint for the time being. So we calculate what the captures are. We set up our context, and then we've gone and calculated this mappings for expression. And in this case, we have this mapping which says, if you are local 0, we are going to rewrite you to environments index 0 captured from local 0. And I don't think we actually need to know what the captured from bit is. It just helps. And then we call this rewrite environment, which is going to update. So our current mappings is going to update our environment. And then we call this rewrite expression. So we recurse into here. And this is the body, which is the if expression, I think, for this is the if expression for bar. And what the rewrite expression is going to do there is it's going to recurse and go over each one of the elements in the sequence. Effectively, what it ends up doing is it's driven by the pair of find captured and rewrite storage. And the rest of it is just walking up and down trees. So what find captured is doing is that for any given expression, it's working out what are called the free variables, or the things that have been must have been captured from an outer environment. So if you've got an application, it's recursing basically things like applications, if, sequence, and sequence points. These are just like nodes in our tree that we know contain multiple expressions, so we know we need to recurse into them. The interesting bits are store, when we're writing to something, and lambdas, where we have capture lists. And so something is captured by an expression if it is in the capture list for a lambda and it is either an argument or a local. And this is why we need to know where something is captured from, I remember now. Because if we capture something from an argument, we need to move it into the environment when we initialize the environment. Whereas if it's captured from elsewhere, we just always refer to it in the environment. So basically, at the end of this Passover foo, we'll have worked out that like foo will have. So bar has the captures list. Bar has the captures list of local 0 because it captures foo's local 0. Foo has no captures, which is why bar ends up being defined on the environment. And then, so if you take a look at of the captures and then the locals, so the locals here, we have local 0, which you've allocated for bar. In bar, we don't have our locals are arg 0, which is for x, and that's it. And when we end up rewriting this, this just ends up being rewritten to, I still don't capture anything, and I still have a local of 0. And this ends up being rewritten to, I capture environment 0, and I still have a local of arg0, which makes sense. But what we really want to do here is get rid of this local 0 bit, because that's where our shadow local is coming from. Because, like in this case, X is going to end up coming from arg0, bar is going to come from the captured environment. So I think we have in rewrite expression, and call rewrite storage recursively on every kind of expression. Rewrite storage looks to see whether or not something was captured. If it was captured, it walks up the chain until it gets to the root and calls rewrite storage on that. Otherwise, if it wasn't a captured thing, this is like a global or a local or an argument. So it looks it up in the mappings and just defaults back to not rewriting it. So rewrite storage is just applying whatever we've got into mappings. So rewrite expression doesn't need to change. What we need to do is get it so that mappings contains not just the, if you encounter this local, then move it into the environment, but also some way of rewriting the locals. So really what we want to do is have like a mutable was find captured. So mappings for expression finds all the captured values, indexes them, and turns them into an environment. I think find captured should return 2 lists instead of 1, and it. Yeah, so if you have find captured, which is all, if we do all the distinct stuff, we can do let captured equals, if we do the find and then the distinct, we'll end up with captured being just the list of all the unique captured values. What we then want to do is like find uncaptured locals expression captured commit is private as well. So the idea of this is it's just going to again be a function, and we can just copy this, and just every time we call find captured, we'll call find uncaptured. This needs to be refactored so that we can pass the what do we want to find from a lambda bit in, but duplicating it will work for now. What are you upset about? Value is not a function and cannot be applied. I mean, that's because we need captured to be there, don't we? And then we can pass captured in like that. And what we're going to do is there we go. I think that does the same thing. What are you? This is now complaining about the fact that we don't do anything with that. What we're eventually going to do is concatenate these two things together so we end up with a map of everything that we need to move into the environment and every local that we want to rewrite the name of. So if you have find uncaptured locals, so down here we've got the body captures, body locals is just, it's just an int. So I guess, what do we want here? We want seek dot count? No. We want a list of all of the local indexes, and then we can get rid of the ones which are in captured, and we should be left with all the ones that need to be rewritten, and we can give them all new values, new numbers. So that would be list. Enumerate range. Is it just this? So it's all of the numbers. This dot map. We want to map it with a local to turn it into a local. And then we want to do list dot. We don't want to distinct it. We don't want a union. Well, actually, we could do this. This is a seek, couldn't we? And then we could do seek dot filter. And the predicate would be captured dot seek dot contains X captured. So everything that isn't in the captured list of seek, we end up with a list of storage refs. So I think that should be it. Let's have a look. So let's run it from the REPL again and see. We can get rid of that breakpoint. Let's put a breakpoint in lower in find uncaptured. Oh, we already have a breakpoint here. So let's see. So we have the body. This is the body of foo. So what are we ending up with here? Find uncaptured, returned, raw view. Let's just have a look at this in the debug console. Yeah, so this returned nothing, which makes sense because there were no values. So how about bar? So bar has one. Is this the right thing? Yeah. So this is bar, but that's right. Bar doesn't have any locals. Let's do that again. I lost track of what was going on. Coco Jack says, will the compiler be available to everyone? The compiler is available to everyone, and you can get it in one of two ways. Let's show you. The first way is if you have .NET installed. Well, both ways you need to have .NET installed. Got to get this. There you go. You do .NET tool install -g Feersum. .NET tool install -g Feersum. So you can install it as a global tool, and then you can do Feersum scheme, and you can get to the REPL that I've just been in. Or you can do something like Feersum scheme spec hello, and it will compile that, and then you can do .NET spec hello.exe. So you can use it from the command line like that. And the other option is if you no, you can download the Feersum SDK by just creating what? No, go away. Oh, dot. Yeah, that looks about right. Don't save. So you create a project file that looks like this. Instead of Microsoft.NET SDK, you can just put 0.2.1. So we can make this file by just doing .NET new and then changing it from from Microsoft.NET.SDK to Feersum.SDK / and then you have to put the / 0.2.1, and then you list the bits of scheme you want to compile like this, and that will download the configure build task from a template, .NET Core, .NET build, and then this will just work with the .NET toolchain. So now we've got a binary in here, .NET 5, greetings.dll. I want to spend a little bit of time at some point and make it so that you don't have to manually change the SDK, and instead you'd be able to have like a .NET template where you can do .NET new console or whatever, just like you would do for C# or F#. I'll have a look and see if I can add it as another language, because you can do like .NET new console -- language F# to get an F# one. It'd be nice if you could do language scheme and get a Feersum one. Anyway, body. So this is body. Yeah, body starts off with local 1. And so what do we do? Yeah, we come in here and we go sequence contains local 0 captured. He's going to return true. Is that the wrong way round? There's this one. Local 1. So that's wrong. Can I just do 3 dots or something? Why was that not? I think it's just because I was editing it while I was trying to run it. Back to the terminal. Can I just go up? No. But I can copy and paste. So in this case, locals is 1. So hopefully we should go 0 to 0. Which means we should only come in here once. And we should say, is local 0 contained in... yeah, maybe we should have evaluated this into a list. How do you list dot distinct? Because I'd really like to be able to see what's in that sequence instead of being confused. Dear. That's not how you copy. I just accidentally Control C. Goku Jack says GitHub and then some stars. I assume you were trying to put a URL in there. I can put a URL in there, I think. My iPad refuses to accept that I might not want to capitalize HTTP. Yeah, that works. GitHub ends up oddly capitalized, but whatever. Where are we? Yes, trying to copy and paste this in the console. Control C, Control V, boom. So locals count is 1. And then in this filter list, we see that the... So the list is 0. What is the problem here? Let's just step out. So expression. Oh, this is store global foo. Fine. How do we know what the locals are? So the problem here is that we're looking at the wrong level. This find uncaptured is not looking at the right level of locals. So this locals, when we're calling find uncaptured on the root, we're getting we're working over everything in the root script, which contains a lambda, but like the locals of that lambda aren't what we need to be dealing with at the root. We need to be dealing with any local definitions. So I think it's not going to be stores. What else do we have? We have a load. We do. So store is taking a storage ref and load is taking a storage ref. So if we never actually use it, we kind of want to recurse in the... So for a load, we'll say... I think I'm going to switch this from just being a plain function so that I can recurse more easily. So captured and node is going to be just a plain function. And then we'll do match node with. So everything works again. We can do let recurse equals find uncaptured locals captured, so that we can just replace all of this. Nope, I wanted to do that and then replace it with recurse. Find next. Yep. Replace, 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 replace. And I'll just manually do that one. Maybe I shouldn't have done that. Looks like I messed it up. Right. So what we can do here... It's like A lambda couldn't contain any uncaptured locals, so we don't actually care about that. That can just go back down to there. So for a sequence point, we care about recursing it. For loads and stores, if an application, yeah, these are all the ones we want to recurse to be able to collect things. So for a store, we've got storage, and for a load, we've got storage. So for a load, we want to produce the mapping from storage, I guess. Which would be let mapping, or we don't really need to be over the top, storage. Which is just going to be equals a function storage, which is going to be, if it's a local, and then it's going to be local x, otherwise it's just empty. So then load, we can do from storage. So then we can recurse in here. We're going to say let inner equals recurse on that, and that's going to then be a list. And then we can say list dot append from storage inner. No, I spelled storage badly. As per. Nice. So we now have hopefully a slightly better way of working out what values aren't captured. Fact. Could we just have this find locals? And then we can do the uncapturedness. That's another point. Yeah, I think so. And then boom. So then this just becomes find locals in that expression. And then uncaptured locals is going to be that. Set operation F sharp. We want the so I think we want to do set dot difference captured. So if you make a set, and then how about we have find locals return a set. So this is going to be set dot singleton. Is that it? Is that nice? And then this is set now empty. And down here, we don't want to do list append. We want to do set dot union. Where else do we use list? Is it this bit? Yes, it is. Set dot union set. And I think this might be set dot union many. Or is it going to be list.map? It's going to be seek dot. What was it before? Seek dot collect pipes to union many. Maybe. Expecting a sequence of sets. That's set dot union. Seek. If we do seek dot collect. Now, why are you unhappy? So it's expecting that to be a set, and it's expecting this to be a set. So this. Why is this set of sets? How on earth we ended up with a set of sets? See, that's a set of sets. That's a set of sets. That. somehow or other we're accidentally wrapping these things. Let's just try building it, because some of these could be just weird out of date errors, but I don't hold out much hope. Let's try putting one of the ones that we are a little bit happier about first, because I think the way that Ironide does this is it tries to match the rest of your branches with the first one. So this is going to be, that's now a set storage ref. Now it's saying Unimany is expecting to take args, find locals. So it's going to be, it takes a sequence of T and a mapper and turns it into a sequence of U. So that should be args. It's a sequence of storage rafts. Ooh. That needs to be seek.map. Now args is a sequence of sets of storage rafts. Okay, so then seek.map. I think we're getting closer. Right. So I think we can just inline that args now. So we have find locals now producing some set. So let's run the REPL again and see what our example ends up producing. So hopefully we'd expect that for foo, Goku Jack says, why F sharp to build a compiler and not C sharp? Why not, really? I hadn't really used F sharp that much. I fancied trying it for something. I like building compilers. It's not a complex thing. Functional languages prove to be quite nice for writing compilers because quite a lot of the time compilers are all about walking over trees and transforming them and things like that, which you can define quite well as functional transforms. I mean, in C sharp, you do it all as like using the visitor pattern and that kind of thing. But so uncaptured locals. What are we at? We are at the expression. Yeah, store global, fine. Yeah. And then how about where are we now? This is the store local 0 sum lambda blah. And uncaptured locals is now empty. Right. Which is good. Is it? Yeah. I think what we can now do is we've got the captured locals. We can make a seek out of that. So this is going to be the sequence of everything that needs to be captured. Capture rewrites. So if capture rewrites is everything that needs to be rewritten because it's been captured, we can make another. We can make another one called let local rewrites. This is going to be uncaptured locals seek dot indexed and then seek dot map. Same kind of function. So we take the index and the storage. And in this case, we're going to say, if you see the storage, give us a local at the index. So this is going to remap things so that you end up with a new local index. And then we do seek dot append capture rewrites, local rewrites, turn them into a map. And we can probably reorganize these things a little bit so it makes a bit more logical sense. So we've got the capture stuff, then the local stuff, and then the return value. That's not what I meant to do. Send it to F# interactive. And then we'll do that whole rewrite thing. So this is mappings for expression. Where does this get called? So we make the mappings, and then we say env equals rewrite env. So I think what we want to do is we want to make rewrite env do take the mappings, do seek dot where fun wherever the storage has been moved to the environment. And you're right. That is not indexed. So we've updated rewrite env so that we're only going to send the things that if the we do let private rewrite locals and locals. So locals is the this is going to be locals. So locals is just a number in this case, but we can do the same thing. If map is empty mappings. So if we didn't produce any mappings, do map to seek like this. And then we do seek dot anything that is a local. And we can just use seek dot count here. Count. Yeah, it should count. Yeah, count by. If it's a local, count 1. Otherwise, count 0. That's all we need to do. And that takes a sequence. What? Sequence of pairs of ints. No. Seek dot sum. That's what I wanted. Then where we rewrite the environment, we can rewrite. So GokuJet says, sorry for asking a lot of questions. Curious about F#. What course or materials do you recommend or use to learn F#? Actually, someone asked the other time about what I had, like whether this was my first F# project, and I said no, but then I remembered I did try something else before, and it was this. Basically, I don't know whether or not it'll be your thing, but you fork this repository. There's a fair number of people who've done it, but not a huge amount. And then you run the program, and what happens is it'll fail at a specific place. So it starts with it starts here with about assertions, which is teaching about this assert equality function, expected and actual values. And so the idea is you see this underscore and you put something in there that'll make it pass. And every time you make it pass, it'll move on to the next one. And so it'll show you more and more bits of the F# like syntax, and also it'll show you ways of using F# and ways of thinking about things functionally. So like for example about lists, it's gonna teach you about what list.head does, list.tail, list.length, and so on like that. So I found that was quite a good way of learning it. That I tried that a few years ago now, and I'd completely forgotten that I tried it. And if I'll just put that in the chat. Ooh. Are we going to be foiled by the fact that copy and paste didn't work earlier? No, that looks like it's worked. There's also F# for fun and profit, which is quite a useful resource. If you just want places to look around, have fun. Let's move this chat box because it's getting in the way. Back on topic. We were going to try and run this and see what it ended up producing. Oh, no, sorry. We weren't going to run it because we weren't ready to run it yet. We wanted to do let locals equals rewrite locals root dot locals context mappings, and then we can say locals. So hopefully, if I start again, we should end up with, when I paste this expression in, we shouldn't end up with a local in sight. It should have got rid of that local. And then, if that looks like it's working, the way I'm going to test the rest of it is just by running the whole test suite and seeing whether or not anything breaks catastrophically. Don't hold your breath. I'm sure it will. At this level of indirection and stuff, it usually goes south. Where we should hopefully, are we in the right expression? Yeah, load. Nope, we are the wrong level. But let's just find out. If we go back to eval, we can just find out what it ends up producing. Here. So we've got the assembly. Then what else have we got? This is maybe not the best way to test it. Maybe the best way to test it would be to do that run spec that we did from before. Let's get a proper one, and then spec, capture, and then we can IL spy it and see. But it looks like it generated something, and it was a valid program, otherwise MonoCessel would have raised an exception. And that still seems to work. So if I do IL spy, that'll show me the IL of spec bin self capture. See, what do we end up with? So it was lambda 0 that was the one that we cared about. Script body lambda 0 was the inner one. Script body lambda 0 is foo, which is the one that we care about. Keeps on scrolling. There's a lot of code here. Script body lambda 1. Interesting. Have I? Oh yeah, script body lambda 0. This is the one. So, oh, that's the thunk for it. And this is the right. This is the ending. This is the result. We now produce only 2 locals. The local slot to hold the environment and the local slot for the spill that happens later, which is another problem for another time. How about no? Okay. So let's run the tests and see how badly we've done. Interesting. There's definitely some fails there, isn't there? You can tell because of the fact that there's just so many red ones. So we've got some which we would expect. Compile and run. Self-capture has failed, but that's just because we don't have a spec for it yet. Index outside the bounds of a list. And a few internal compile errors. None of this is great. Capture test. Capture test sounds like what we should probably be doing. So let's try running. No, not the REPL. Let's try running the compiler against capture test and seeing where it ends up. Where it ends up throwing. Hopefully, it's a fairly obvious one. Internal compiler error. What's the message? Unexpected storage in capture chain local 0. Let's try that again. So let's try that again, but let's put a breakpoint in here first. No locals, no environment. Then this one has no captures. Okay. Then this one does have some captures. So let's see what happens here. So the environment should hopefully contain the captured value. No. Locals is still 0. So what was the mappings? The mappings is empty. Ah, because it would have been captured one level further up. So really what we care about is what the mappings are. I think it might be in the change I made to rewrite environment here. So environment 0, local 0. What does env end up being? No, the environment is correct. What does locals end up being? 0. Good. So there was a local and we've got rid of it. So that bit's working correct. Let's just carry on until this throws. And then try having a look further up the stack. I mean, yeah. So what capture chain? So we've got captured local 0 that's not been properly rewritten in a load. Why would that be? What have I changed in there? I thought so. Find captured is still the same. Find locals is still the same. Mappings for expression has changed. What has happened to lows? So rewrite environment is just filtering out the environment stuff. And then we rewrite the locals. So rewrite expression is not rewritten storage on a load for some reason. Let's have a look at the bound expression that we were asked to omit. Wow, that is a bad typo. Yeah, Load captured local 0. I mean, that looks wrong, yeah. That's in a sequence point. Right, what's root.body? Capture test line 3, capture test line 3. It's this lambda. And it's column 33 and 34, which is like there. So basically, that what? That's not a local though. That's an argument. That's a captured argument. So that like this lambda declaration is using a form of the lambda where you say bind all of the arguments to this list called A, and then the body of the lambda is another lambda that just returns the captured list. I don't understand why we have made that a local. Unless... Well, I mean, I understand why. It's a bug somewhere in our lower change. I understand it at that level. You know, I think... I wonder... Have we not rewritten the captures, maybe? Let's... We can just try this simple expression in the REPL, in the debugger, and see what we end up with. Debug. So, rewrite root. The root is this. Well, let's just print it out in the debug console. Sequence point. It's a sequence containing one thing. No. Yeah. It's a sequence containing one thing. The sequence point, which is which wraps a lambda, which takes a simple thing. So it's got a simple argument list of just bind everything to A. And the body is the sequence of containing a single thing, sequence point, which is the lambda, which takes no arguments, and the body is to load the captured arg0. So at this point, everything is good. The inner lambda captures arg0. There is no environment. The outer one also has no environment. Oh no, so this one has an environment because it might need a capture chain stuff. So it's got an environment, but there's nothing in it in its specific one. What we need to do is basically replace this environment with one that contains arg0. Why is that going wrong? So mappings for expression. There's nothing in there. Okay. Rewrite locals. Okay. This is still at the outer level. Then rewrite expression is going to recurse. So now root should be the lambda. So this is the outer lambda. Where's the root of the outer lambda? So the captures are still empty. Mappings for expression. This is where we'd hope we end up with a mapping for that captured value. arg0 to local 0. Right. Why though? It must be this. So let's just step to the end. And then do the same thing again. No, wrong terminal. So this. I think is fine. Then we recurse. This is the body of the outer lambda because it contains the inner lambda declaration. What is captured rewrites? Captured rewrites. Sure, show me the results. Is arg0 end of environment arg0. So that bit is working. Now what does uncaptured locals do? Why is arg0 an uncaptured local? Because it's the captured stuff. What's set difference doing? What have I messed up? the help here for set difference says set difference returns a new set with all the elements from the second set removed from the first. And I thought captured, that's the second one. This was the first one, except for the fact that that's not what we've done. We've done this the other way around. Now, what we were effectively doing is generating rewrites correctly for all of the captured things and then generating rewrites to put them all into locals, which is definitely not what we wanted. And then that local stuff didn't match up properly, and then that's where hopefully all of the indexing errors and stuff was coming from. So now, if I do this, hopefully I'll end up with a lambda rather than an internal compile error. Copy, paste. And then let's just disable all the breakpoints because we're super optimistic. Compiled procedure. What about that? And then if we call that compiled procedure with 1, 2, 3, we should expect to see another compiled procedure, which is the lambda inside it, which then if we call that, we see the list, which was captured from the outer one. So I think that's that all working. I think that's the bug fixed. Let's run the tests and find out. If this goes well, we should expect to only see the failures being from the fact that we've just added this new spec. Which, yeah, self-captures, snapshot does not exist. That's the kind of test failure we would expect to see. Snapshot does not exist. Right, so now if I do update, so run task, update snapshots, what do we end up generating? So we should probably do that. I'm just going to run update snapshots again in the background. And then we can go over what we've got. Let's have a review. So, self captures, we introduced the... I'm going to edit the file yet again. Now we can leave those comments in. So yeah, we have foo, which captures nothing. We have bar, which captures itself. And then we end up, hopefully, not emitting a local for it. We have the changes to lower. So we've got this new find locals, which finds all local variables in the given node. This is later used to compact down local declarations to remove shadow locals from captures. Let's go for the actual proper editor for this. Boom. Then we also have the change to mappings for expressions so that we build up the captured list and we build up the uncaptured locals list. And then we build a mapping from all of them. And then we have the changes to rewrite environment and the new rewrite locals. So this one, rewrite the number of locals based on mappings. So for the environment, we now pick out only things that have been moved to the environment. For locals, we pick out only the things that are locals. And then we've changed rewrite. And down here we can say update our environment and local size if captures were found. And then instead of just using the original roots locals, we use the rewritten value. We've got a new parse and we've got a new output, which is just 9 and no exceptions. Everything else passed. So I'm going to commit that. Rewrite captured, uncaptured locals in lower. If captures if captures were moved to the environment, you need to clear out there. We need to ensure we need to reorder locals to ensure that there are no empty slots. This avoids fixes. And then the original bug was digs into history. And let's publish that and find out if it works on the build server. Right, so I think that's probably it for today. I'm pretty pleased with that. That was quite a nice bug to track down and fix in the end. So it wasn't really a bug. It's more of a shortcoming. We were just wasting, well, not really, wasting space. I assume that the JIT would have not allocated anything for those locals anyway, but it did just make the IL more difficult to follow. Why have you not published? Don't know. I quite like the new big publish button in VS Code. So with that fixed, I guess the plan now is to start working in the next few streams on moving some of trying to implement some more of the standard library. So at the moment we have this Shrifa library which has some C# code which defines methods and things that you can call from schemes. So we have this pair of attributes, Lisp library and Lisp built-in, that'll be used to mark up C# code, and then each one of these ends up being added to an environment so that you can call it. So we could go through and implement the whole of the R7RS standard library like this, but where's the fun in that? Especially now that we've got the ability to call our compiler. So in the these examples, we're building things using our SDK. So it's not actually linked in directly. I've got a directory build props that goes and picks out, sets the language targets appropriately to point to our language targets, Feersum SDK targets. And then that means that the .NET SDK knows, oh, if I'm in a scheme project, I'll use the language targets from that. And then we've got a few declarations to say, like, link in the standard library, link in the compiler, and we say no implicit reference and stuff like that. So basically we've stubs things out so that we're using the same SDK, but we're using the local copy of the compiler. And with that done, it should be possible to start defining parts of the scheme standard library just as like a new project. So I'd be able to like create a new project and do Feersum standard lib. The main problem is that at the moment, to be able to compile, we need to depend on this. We need to depend on Feersum, the main project. I would like it to be that the package, the tool that you install, contains the standard library. So we've got a bit of a circular dependency, and we may end up having to do a little bit of build to build things twice in different configurations and that kind of thing. But I'll do some investigations offline and we'll go from there. So if there's any questions, feel free to shout out. If not, then I'll wrap things up. Thanks for watching, and I'll see you next time.